So I want to use the example of OAuth 2.0, which is a very commonly used authorization framework for the web. It's built for the web. It may or may not work for a given IoT use case, but it's a good example, and I want to pull out a few concepts that are important. And even if you don't use OAuth 2.0, you need to think about some of these concepts. The two big ones are token scope and token lifetime. Token scope describes what privileges are associated with the token. So what can the bearer of this token get access to? Token lifetime describes when the token expires. And there's this notion of refresh tokens versus access tokens. Access tokens will be used to access the actual resource you're trying to get to, the protected resource. These tokens are often short-lived, narrowly scoped, and they can be self-contained. So the decision on the resource server is actually can be optimized and quick, and it doesn't need to do any kind of back-end lookups. It just looks at the token that it received, and it can make a decision with the information there. Refresh tokens, on the other hand, are used to get new access tokens when the old access token expires. These tokens are often long-lived. They're more widely scoped, so you may want to go and get access tokens for a variety of different scopes. And they're not self-contained, specifically. And what this enables is the authorization server that's making the decision as to whether it should give a new access token based on a refresh token. It can decide if there's been a revocation of that authorization. And that's what you want to have with IoT as well. You want to have that passive expiration. So if it's revoked, once the current set of access tokens expire, there's no more access. There's no way to go get another access token. You don't want to be in this situation where you have to pull an unused IoT device out of a closet, hope it still boots up, and do some kind of factory reset in order to deauthorize it. You want to be able to do that passively. So this is a snippet from the OAuth spec, RFC 6749, depicting the refresh token flow. You can see in the middle, the access token is used to access a protected resource, the resource server. In steps E and F, that's where the access token's expired, and you'll get an error back. And then down at the bottom, G and H, you can see the refresh token is used to go get another access token from an authorization server. Hopefully that helps you visualize that a little bit better. So let's think about authorization in the context of IoT or of an IoT device. We talked about that authentication needs to go both ways. Authorization needs to go both ways as well, or at least we need to think about it in both directions. We need to think about who has access to a device, who can send commands to the device, who can read data from the device, and so forth. We also need to think about what does a device have access to? What rights does it have when it connects to a web service, for example? We want to use the principle of least privilege. We don't want to give more privilege than necessary. And this is a really common problem with IoT, and I think it's because it's so easy. It's so easy to just give the device total authorization for the service it's connecting to, because then you won't have any more problems. You won't have any authorization errors, and everything will just work. The problem is, if the device is only using 10% of that authorization, if your device gets hacked, now the attacker has access to all of it, even though you weren't using it. You also want the expiry. I talked about the passive expiration. You also want to be careful when you're passing your tokens. Tokens are, of course, made to be passed for specific purposes, verification, for example. But you want to make sure that you've authenticated the recipient before you send your token. If you're sending it up to a web service for verification, make sure it's over HTTPS. If you're sending it if you're provisioning a new device, like our TensorWatch case, authenticate that new device before you send over the token. As you'll see in a few minutes, Google services like Firebase on Android things, the Firebase SDK will manage tokens for you. You don't have to worry about this token management, which is great. So let's go back and look at authorization in our TensorWatch scenario specifically. We start in this state, where we assume the phone is already authorized to set up new devices with these cloud services. And the phone is implicitly authorized to set up the TensorWatch device because it doesn't have any policies about that. And where we want to be after we provision is we want to have a two-way authorization with Firebase. So we're going to use the Firebase real-time database, and it can sync down to the device. It can also sync data from the device up to the cloud. And when it syncs down to the device, we can actually use that to issue commands to the device. And so there's an authorization where Firebase is authorized to give commands to the device, and the device is authorized to push data back up into Firebase. Quick review, we talked about authentication, checking that something is genuine or valid. Authorization, checking that it is allowed to do what it's trying to do, and attestation, which is checking the integrity of a computing device specifically. And now Wayne is going to show us.
So we have internet access on our device, and we have a key. So now let's quickly talk about how we're going to go about talking and getting cloud services enabled on this device. So we're going to talk about Firebase and Cloud IoT. So the first thing we need to do is, on the phone side, we need to set up Firebase. Firebase is great because it works on Android, iOS, and web. So the phone app could be on many kinds of devices. You create a Firebase project ID, and we're going to use that on both the phone and the device. And then we ask the phone user to authenticate with their username and password, pop up a dialog box, and we'll get a token that we then pass down the encrypted pipe that we created earlier. So here is a bit of a code snippet for it. You can see at the top, we're doing the sign-in request. And it's interesting because we're only requesting scope for the email ID. So we don't want to have full Google access or access to their files or email or anything like that. We're just asking for their identification details because we're trying to limit scope, like what Darren talked about earlier. We end up getting a JSON web token that we can then pass in to sign in with Firebase, which then allows our device to interact with Firebase as well. But we ship that token, we ship the previous token off to the device so it can log into Firebase and do things with that. So on the other side, we take the Google token, pass it to Firebase, and authenticate with that. And the device now has access to the Firebase real-time database. The code snippet looks very similar on the device as well. Because the Android Things device is regular Android, we use the same code just like we do on a phone. We get the credential, we pass it in to sign in with credential to Firebase auth, and now we're done. We now have a bidirectional authorization, and our TensorWash now can fully participate with the Firebase real-time database. So let's switch gears to finish up. We can also talk to Cloud IoT Core. So imagine you're running a laundromat with thousands of machines in thousands of locations, and you want to do predictive breakdown analysis. So we want to push the data from these devices to Cloud IoT for analysis. So in Cloud IoT, we register the devices. You'd have an app on your phone with some credentials, and you would take that public certificate that we created earlier, and you would give that to Cloud IoT so that it knows the device and that it can trust it. We then use MQTT to send requests to Cloud IoT with our device ID and signed with our key. Cloud IoT can verify that this message is legitimate by verifying this key and checking it with what it received earlier. So then we send the MQT request using TLS, and we use TLS so that our device knows that it can trust who it's sending the data to. Because remember, both sides need to check the other side. Here's a very quick little snippet that shows how we put in some of the project IDs and things like that. And we're going to be releasing this sample too soon that shows how to do Cloud IoT Core on Android things. And so the nice thing is that publish device state at the bottom basically takes any binary blob that you want and sends it off to Cloud IoT, and you don't have to worry about generating any of the messages. So we talked very quickly about Cloud IoT and Firebase. What are some other options of things you can do? Well, we also have Smart Home, which is our new way of controlling devices from the Google Assistant. So you can do things like, if you've got light bulbs, you can say dim the lights a little bit. Or in the case of our washing machine, if you implement Smart Home, you can do start my washing machine, and it'll kick off a load of laundry from the Google Assistant. And so by implementing Firebase, you write a small webhook that plugs in a Smart Home, and then your device can be enabled with the Google Assistant. And then finally, you can actually embed the Google Assistant SDK into your device, which means that you can actually talk to the washing machine and give it direct commands to the machine directly, which is kind of cool. So what's next? We have a factory key provisioning story coming soon. We're basically going to have a hardware device that's going to allow you to add keys onto Android Things devices. It's something you could do yourself or when they're being produced. And this is how this key is going to get onto the device. So if you have a developer kit, you won't be able to test the key signing correctly because you won't have an official key from Android Things. But we're going to be releasing the tools to be able to do this soon. And remember that Nearby Setup API is coming soon as well. And that's going to be really nice to make provisioning these things really easy. So in summary, go visit our site at androidthings.with